Hi, chemistry. I want to talk today a little bit about the basics of reactions. So we're going real basics here. We're going to start talking about chemical reactions next. And so when we're looking at a chemical reaction, it can look like a lot of symbols that don't have a lot of meaning, but just like the periodic table, that is a tool just packed full of meaning. You just have to learn how to read it. The same is true for a chemical reaction. So how do you know that it is a chemical reaction? Well, that's a fantastic question. So first of all, there are three different types of reactions that we may be talking about. One is a physical reaction, one is a chemical reaction, and one is a nuclear reaction. Now, we talked about chemical and physical reactions or chemical and physical changes and a little bit about nuclear changes way back at the beginning of the year, probably within our first week. So now would be a really good time to pause the video and see, can you write a definition or give me an example of what a physical reaction is, what a chemical reaction is, and what a nuclear reaction is. So a physical reaction would be a change that occurs, but the substance you're dealing with is there in the beginning and the end. So the substance doesn't change. And that little triangle for me means change. A chemical reaction is basically based on the same definition. So it's a change that occurs where the substance does change. So if you get a new substance, you're dealing with a chemical change. If you have the same substance there in the beginning and the end, you're dealing with a physical change. So a good example of a physical change would be like the evaporation of water. If you have liquid water and then you heat it up and it turns into gaseous water, you still have water there at the beginning and the end. It's just in a different form. That would be a physical change. But if you start with something like methane gas and combine it with oxygen, and you actually make water along with carbon dioxide. Water wasn't there in the beginning. Water's only there at the end. And now that we've talked through chemical bonding a little bit more, this becomes more significant than it was in the beginning of the year, because we know that the bonds between carbon and hydrogen have actually been broken and reattached to that oxygen. Now we have new bonds that are formed. We have an oxygen-hydrogen bond that we didn't have before. We have a new bond between the carbon and the oxygen that we didn't have before. So when new bonds are formed, we have a chemical reaction. Now, nuclear reactions are discussing a change as well, but it's not a change in the bonds like a chemical reaction is. It's actually a change in the nucleus. So if you have hydrogen, which has a 1 proton and a 1 electron, and that combines with another hydrogen, that's 1 proton and 1 electron, and you get a totally new nucleus that now has 2 protons in it and 2 electrons floating around. That's a nuclear change. When the nucleus changes and you get a completely different element, that's a nuclear change. When the atoms stay the same, we still have carbon, it's just bonded to something different. That's going to be a chemical change. So we're going to talk about what a chemical reaction looks like. And you can see that a little bit in the one we just talked about. We had methane oxygen, water, and carbon dioxide. That's a chemical change. So characteristics of a chemical change would be that the same atoms are present in the beginning and the end, but you have different compounds. You have different molecules, you have different formula units, right? Your bonds have rearranged. So same atoms, different arrangement. A couple other things that are characteristic to all chemical reactions when you see them in symbol form. Notice that there's an arrow in the middle here. This arrow separates the reaction. It separates the before with the after. So CH4 and O2 are the things we start with. They're the things we have at the beginning of the reaction. They are the things we have before a change occurs. And then there's this arrow that separates those things we have in the beginning to the things we have in the end, the substances that are present after the change occurs. That would be water and carbon dioxide. Now, we have special terms for these, and so those are your vocab words number 1 for today. The things we have in the beginning, the molecules, the compounds, the formula units we have in the beginning, those are called the reactants. The reactants are the things we have in the beginning. The substances we have after the change has occurred, those are called the products. The products are the things we make. And you can see I have a picture here off of study.com. If you were baking, you would have these same things. The reactants we would call the ingredients, right? When you're baking or when you're cooking, the things you start with are called the ingredients. Those are our reactants. The thing you end with, which is this lovely cake, that is your product. And actually in baking, we might call it a product too. What are you making? I'm making a cake. My cake is my product. So we have this same thing in chemistry. Now, we understand this in baking, but we tend to forget these things when we're just looking at symbols and not pictures. And so one of the big concepts that you need to train your mind to see when you're looking at these symbols is the fact that reactants are used and products are made. I have another example of this. Okay, so I'm going to take away that picture. I'm going to give you a new picture. Here are my ingredients, right? These are my reactants. And we're training our eye when we look at the symbols to understand that reactants are used. So as this reaction proceeds forward, the reactants are going to disappear. But they don't just disappear into thin air, right? The atoms are pulled apart from one another. The atoms are rearranged, new bonds are formed, and we have something different in the end. Reactants are used, products are made. Reactants are used, products are made. Reactants are used, products are made. So in the end of a reaction, we are going to have less reactants. We are going to have more products. The same atoms are still present, but they are rearranged into something different. New bonds have been formed. we have something different now. Now, if the reactants are perfectly made or perfectly used, then we'll have no reactants, right? But in baking, this rarely happens. Usually you don't have the perfect amount of flour, eggs, and baking soda, right? Usually we have a whole bag of flour, we take a scoop out, we use it to make our pancakes, and we still have some flour left in the bag, right? So in the real world, we're going to end up with less reactants, not no reactants, right? Same is true in chemistry. Usually, as a reaction proceeds forward, we get less of our reactants and more of our products. We usually don't end with zero reactants and all products, right? But where does that reaction stop is a really tough question, and it's going to take us a while to get there. So until we get there, we're going to treat reactants as if we use them all, and they all get turned into products. And then as we start to get comfortable with these ideas and these symbols, then we'll start looking at it a little bit more realistically. Okay, so the other part of reactions I want to talk about are the symbols. You can see that whatever reaction happens, whether it's a reaction where you're baking or a reaction where you're mixing chemicals, usually you have a couple symbols that appear. And one of the symbols is a plus sign, and the other symbol is an arrow. So we need to talk about what these symbols mean and what various words are that you're going to see for each of these symbols. So the plus sign can be used on the reactant side or the product side. In the case of our pancake recipe, we see it only on the reactant side. Same thing with this zinc and iodine reaction. We see it only on the reactant side. But in the case of methane, reacting with oxygen to form water and carbon dioxide, you see the plus sign on both sides, right? It's just that plus sign just designates the space between molecules. It separates molecules. It lets you know that the molecules are not bonded. Methane is a different molecule than oxygen. Water is different than carbon dioxide. Those two are not joined together. They might even be in different states. One might be a liquid, one might be a gas, right? So that the plus sign just separates out things so you know they're not bonded. So that plus sign might be communicated using different words. This would be a really good place to pause the video and see how many different words can you come up with that could replace that plus sign in a sentence. You might even see the word plus. And is a really common word. You can also see words like reacts with or combines with, or it could be more specific like combusts, it's supposed to be an M, with, right? Or you could just see the word with. So it gets a little bit trickier when we're going from words to symbols or symbols to words, because this plus sign, while we have one symbol to designate what we mean, we have lots of different words that we could use. So you're going to have to work with this a little bit and stay aware of what kind of words they use so that you can recognize these words as that plus sign that's just separating the molecules that are together, so that you can write your own reaction. Okay, similar to this arrow. So this arrow, just like the plus sign separates things, the arrow also separates things, but it's going to separate the reactants from the products, like we talked about before, the things that are used with the things that are made. It's going to denote a change. it's going to tell you that a change occurred. Again, there's lots and lots of different words that can be used in place of that arrow. So now would be a good time to pause and see if you can come up, how many of those words you can come up with. To form would be good words. To make. Flour, eggs, and baking powder make pancakes. Zinc reacts with iodine to make or to form zinc iodine. You can also see specific ones like combusts to form. Sometimes if the reaction is flipped, like ZnI2 goes to Zn plus I2, you can see a word describing what happens to that molecule. So you could see like decompose to form, or falls apart to form. So again, there's lots and lots of different words that can represent that arrow depending on the context. So as we move into reactions and we start to see these molecules and formula units in the reaction, stay aware of what kind of words are going to represent that arrow. This is going to be your key. If you ever get lost inside a sentence and you can't quite figure out where the arrow goes, look for where the reactants are separated from the products. Look for where the things that are used are separated from the things that are made, and that is going to be where that arrow goes. Okay, so those are your reaction basics. We will come together to talk more and more about reactions in the next couple days. Let me know what questions you have right now, and I'll see you in class.